positive charge, +1. Calcium has two positive charges. So if you have X amount of potassium and you have the same amount of X amount of calcium, because calcium has a positive charge, if the amounts would be the same, then the movement of calcium inside the cell would be more, creating a more electropositive inside the cell. So what I am trying to say is that the amount is not the same. Most probably the amount of potassium might be 2x and the amount of calcium movement in this plateau phase might be just x, because this has a 2 positive charge. I think it makes sense. So the positive charge in all is balanced by both these ions. Now this, the phase 3 is caused by potassium efflux. Basically what is happening is that the potassium channels which have opened out here in the plateau phase is still open, but the calcium channels which had opened out here in phase 1, in phase 2, now have closed. And that is why closure of these calcium channels only now causes movement of potassium outside the cell. If you move potassium outside the cell is losing its positive charge. That means the electronegativity, which was earlier established at -90, will be starting to come back again. That is why we see a fall in the action potential. Now, the last phase is phase 4, which is also caused by slow leaky potassium channels. Why do we call it slow and leaky? Because it helps to establish the resting membrane potential. Why is that so? This is an important point to keep in mind. Resting membrane potential is always by potassium efflux. And if you keep this concept in mind, that this has come down to a point of about say -80 millivolts or -70 millivolts, then potassium efflux would cause more electronegativity inside the cell, and that would help the cell to go from -80 millivolts to back to -90 millivolts and cause electronegativity inside the cell. Now these potassium channels always stay open till the next time the next sodium influx begins due to stimulation, electrical stimulation. Till that point, these slow leaky potassium channels will remain open and another cycle will begin. One basic principle that I will highlight here again is that an electrical stimulation is necessary for a cardiac myocyte to open its ion channels. If there is no electrical stimulation, these ion channels, potassium, calcium, sodium, will not open. And if these ion channels do not open, the ions will not move, whether it may be inside the cell in case of sodium and calcium, or outside the cell in case of potassium. Ion channels will not move. Electrical stimulation, opening of ion channels, movement of ions, cardiac action potential. Now, for example, if there is a ventricular myocyte sitting out there, how does it get its electrical stimulation? Well, the SA node causes conduction, it sends it to AV node, AV node sends it to the bundle of his, then to the Purkinje fibers. The conduction goes from the T tubules gives it to the ventricular myocytes. That is the electrical stimulation causing this opening of the sodium channels. If you do not pass on the electrical stimulation, that is a dead tissue there would be no opening of calcium channels, there would be no stimulation, no action potential, and no cardiac contractility. This is the ventricular action potential. Next video would be on nodal action potential.